A complete course on GHG emissions.
Prepared by Planet Sustech Private Limited. Planet Sustech Private Limited is a sustainability solutions company catering to global clients for their ESG requirements, like carbon footprints measurement, ESG or sustainability reports, ESG ratings, net zero goals, value chain assessments, and lot many other things. This course is for those who want to understand the basics of GHG emissions, which is primarily fundamental to sustainability. After completing the course, you can apply for the certification as well, which can be achieved after successfully completing an online assessment. This course has tried to cover not only the very basics of GHG but also the topics which are widely discussed and used in day-to-day ESG activities. You can go through the entire content here and find out what's in here. What is an emission? Let's discuss. In environmental and climate work, we mainly talk about gases and particles released into the air from human activities. Emission means something that is released into the air. Let's see some examples from the daily life. When a diesel generator runs, smoke from the exhaust is an emission. When a car, truck or bus burns petrol or diesel, the exhaust gases are emissions. When we burn LPG or natural gas in a boiler or stove, gases going out of the chimney or exhaust are emissions. When waste decomposes in a landfill, methane gas is emitted, that is emission. So, emissions are gases or particles going into the air because of our activities.
Let's try and understand how emission is different from pollution. Emission is about the act of releasing something like gas, particles into air, and sometimes into water or soil. For example, a diesel generator releases exhaust gases, that is an emission. A cow releases methane gas, that is also an emission. Now let's talk about pollution. Pollution is when those emissions, or discharges, harm the environment or human health, or make the quality of air, water, or soil worse than acceptable limits. In short, emission is release. Pollution is harmful release, after certain limit, that degrades air, water, or soil quality or harms health or climate. Let's try and understand difference between air emissions and GHG emissions more precisely.
Air emissions or air pollutants is a broad term. It includes anything released into the air that can affect air quality or health. It includes the following gases: dust and particulate matter, sulfur dioxide, nitrogen oxides, carbon monoxide, volatile organic compounds, heavy metals in air, like lead, mercury, odors, greenhouse gases.
GHG emissions are a smaller group inside air emissions that specifically affect climate change by trapping heat in the atmosphere. It includes carbon dioxide, methane, nitrous oxide, multiple fluorinated gases. Impact of air pollutants and GHG. Air pollutants mainly affect local air quality and human health, for example, breathing problems, smog, acid rain. GHGs mainly affect global climate by trapping heat and causing global warming. Let's try and understand from some examples where both appear together.
In the below two examples you can see what is air emission and what is GHG, where both of them appear together.
Now let's see some examples of air emissions that are not GHGs. Dust from a cement plant bag filter outlet, PM, affects air quality but not a greenhouse gas. Sulfur dioxide from a furnace, causes acid rain and health impacts but is not a greenhouse gas. In summary, all GHG emissions are air emissions, but not all air emissions are greenhouse gases. Air emissions focus on health and local environment. GHG emissions focus on climate and global warming.
Now it's time to talk specifically about GHG. Let's learn. What is GHG? Greenhouse gas or gases. GHG stands for greenhouse gas. These are gases in the atmosphere that trap heat, like a blanket around the earth. More greenhouse gases mean more heat trapped, which leads to global warming and climate change. What are the main greenhouse gases? Let's see them. Carbon dioxide from burning coal, oil, gas, diesel, petrol and other fossil fuels. Methane from landfills, agriculture and leaks in oil and gas systems. Nitrous oxide from fertilizers, some industrial processes and combustion. Fluorinated gases from refrigerants and some industrial uses. When companies report GHG emissions or carbon footprints, they add all these gases together and expresses them in one common unit called carbon dioxide equivalent. Let's start understanding what are the various categories of emissions in GHG. They are Scope 1, Scope 2 and Scope 3 emissions. What is Scope 1, Scope 2 and Scope 3 emissions? To organize emissions and avoid double counting, they are divided into 3 scopes. Scope 1. Direct emissions from sources that the company owns or controls. Scope 2. Indirect emissions from purchased energy such as electricity, steam, heating or cooling. Scope 3. All other indirect emissions in the value chain, both upstream, suppliers, and downstream, customers, end of life, etc. Let's see an easy and tricky way to remember. Scope 1. You own and control the source. Scope 2. You buy the energy. Scope 3. Everything else linked to your business in the supply chain and product life cycle. Now let's get deeper and understand more in detail. Scope 1. Direct emissions, with categories. Scope 1 emissions come from sources owned or controlled by the company. These are typically grouped into stationary combustion, mobile combustion, captive energy or captive power generation, Process emissions. Fugitive emissions. Biofuel or biomass combustion. What is stationary combustion? This is fuel burned in fixed equipment that does not move. Examples in a factory. Boilers producing steam or hot water using diesel, furnace oil, natural gas, coal or biomass. Furnaces and ovens used in production. Hot oil heaters. Fixed diesel generators used for power. Examples in buildings or offices. Central heating systems using oil or gas. Fixed diesel generators for backup electricity. What is mobile combustion? This is fuel burned in moving equipment. Examples: company-owned cars, trucks, buses and vans. Company-owned forklifts, loaders and cranes that run on diesel or petrol. Motorbikes owned by the company. More tricky examples. If the company owns the vehicle and pays for the fuel, the emissions from that fuel are Scope 1 mobile combustion.
If the company owns or controls the vehicle, example company owned or company leased, and the fuel is used in that vehicle, the emissions from that fuel are Scope 1 mobile combustion.
What is captive energy or captive power generation? Sometimes companies generate their own power or steam on site. This is called captive power. Examples: gas turbine or coal-based captive power plant inside the factory boundary. Large diesel generator regularly supplying part of the plant load. Biomass-based boiler generating steam and electricity for the plant. The fuel burned in these systems creates Scope 1 emissions, because the company owns and operates the plant. What are biofuels and biomass? If the company burns biomass or biofuels, the combustion is still a direct Scope 1 source. Examples: rice husk boiler in a food plant. Bagasse boiler in a sugar mill. Biogas used in a boiler or engine. Biodiesel used in company vehicles. Carbon dioxide from biomass is usually reported separately as biogenic carbon dioxide, because the carbon originally comes from plants. Methane and nitrous oxide from biomass combustion are still counted in total GHG emissions. What is process emissions? These are emissions from chemical or physical processes, not from burning fuel. Examples: carbon dioxide released from calcination of limestone in cement or lime kilns. Process carbon dioxide from certain chemical and metal production processes. What are fugitive emissions? These are unintentional leaks of gases, not from a controlled chimney or exhaust. Examples: leakage of refrigerant gases from chillers, cold rooms and air conditioners. Leaks of natural gas or other process gases from pipelines or valves.
Simple rule to explain. If the company owns or controls the chiller, AC, cold room, or refrigeration system, any leakage of its refrigerant gas during operation, maintenance, or at end of life is treated as Scope 1 fugitive emissions. Examples of refrigerant gases for Scope 1 fugitive emissions.
Here is the quick summary for Scope 1. If your company owns and controls the equipment, and it burns fuel, carries out a process that releases gas, or leaks gas, those emissions are Scope 1. Now it's time to learn Scope 2. Scope 2 means indirect emissions from purchased energy. Scope 2 emissions are emissions from the generation of electricity, steam, heating or cooling that you purchase from another organization. The emissions physically occur at the power plant or energy supplier's site, but they are counted as your Scope 2 because you use that energy. Examples: electricity purchased from the grid and used in your factory or office. Electricity purchased from a private power producer. Steam or hot water purchased from a neighboring power plant. Chilled water purchased from a district cooling system. Easy rule. If you burn the fuel yourself, it is Scope 1. If someone else burns the fuel to produce energy that you buy, it is Scope 2. Now finally let's study Scope 3. Scope 3 means other indirect emissions. Scope 3 emissions are all other indirect emissions that occur because of your business activities but are not Scope 1 or Scope 2. They occur in your value chain, both upstream, before your operations, and downstream, after your operations. Simplified Scope 3 categories with examples. Upstream activities means before your processes. Purchased goods and services. Capital goods. Fuel and energy related activities not already in Scope 1 or 2. Upstream transportation and distribution. Waste generated in operations. Business travel. Employee commuting. Upstream leased assets. Downstream activities means after your processes. Downstream transportation and distribution. Processing of sold products. Use of sold products. End-of-life treatment of sold products. Downstream leased assets. Franchises. Investments. Very short summary. Scope 1. Direct emissions from your own sources. Scope 2. Indirect emissions from purchased energy. Scope 3. All other indirect emissions in your value chain before and after your operations. Now let's move on to the most used topics. What is an emission factor? An emission factor is a simple conversion number that tells you how much greenhouse gas is emitted per unit of activity. General formula. Emissions in carbon dioxide equivalent is equal to activity data multiplied to emission factor. Activity data is how much fuel, electricity, distance, or material you used. Emission factor is how many kilograms of carbon dioxide equivalent are emitted per liter, per kWh, per kilometer or per kilogram of material, etc. Now, let's look at some practical examples. Example 1. Diesel in a generator. All these examples you should work on your own to practice calculating emissions. Emission factors are important because we do not measure carbon dioxide directly from every exhaust. Instead, we measure easier values such as liters of fuel, units of electricity, or kilometers traveled, and then use emission factors to convert those into emissions. Now let's learn a key concept, that is GWP. What is GWP, or global warming potential? GWP stands for global warming potential. GWP tells us how powerful a greenhouse gas is compared to carbon dioxide over a specific period of time, usually 100 years. By definition, carbon dioxide has a GWP of 1. If another gas has a GWP of 28, it means 1 kilogram of that gas has the same warming effect as 28 kilograms of carbon dioxide over that time period. Let's see typical approximate GWP values for understanding. GWP of carbon dioxide is 1. Whereas methane's GWP is around 28, and nitrous oxide GWP is around 265. Now you can see how powerful these gases are comparing carbon dioxide. Even if they are released less, but their potential effect is multi-fold. To convert a gas to carbon dioxide equivalent, we multiply the mass of the gas by its GWP. For example, methane. For example, methane emissions is 10 kgs. And GWP of methane is equal to 28. Carbon dioxide equivalent will be 10 kilograms multiplied to 28, which comes to 280 kilograms carbon dioxide equivalent. This shows that a small quantity of a high GWP gas like methane can have a large impact on total carbon dioxide equivalent. In most practical work, emission factors are already expressed in carbon dioxide equivalent and already include the effect of GWP of all gases involved.
Let's try to understand now little less known term. Kyoto basket. It refers to the group of greenhouse gases that are controlled and reported under the Kyoto Protocol. Instead of tracking only carbon dioxide, the treaty covers a basket of 7 gases given below.
All these gases are converted into carbon dioxide equivalent using their GWP and then added together for a country's or company's total emissions. How to use GWP we have just learned. Try using the concept and convert these gases to carbon dioxide equivalent on your own. Now we have almost finished studying the fundamental concept which gives us fair understanding of air emissions, pollutions, GHG, GWP, Kyoto, Scope 1, 2 and 3 emissions and their categories. Hope you have understood those concepts and, if not, I would request to go back and study it again through this video. This requires few more rounds of study to get a good grip on the concepts. Once you are done reading it through properly and got the concept clarity, we will do some practice questions. Let's start with practice question 1. Classify the scopes. Now, I would suggest to stop the video here, read the question on your own. Try to understand the question and try answering on your own. Practice question 2. These are those very important tricky questions which will actually test your concepts. Most of ESG practitioners get confused in categorizing the emissions into correct categories. Sometimes what apparently looks like Scope 2 comes out to be Scope 3. Same happens to Scope 1 also. I would suggest you stop the video and slowly go through all the single question. Once you read these questions and answers patiently, you will have ample of clarity in your understanding and would be in better position to identify which item under which situation is mapped to which scope. Now let's see some tricky examples related to common confusions in Scope 1, 2 and 3. Example 1. Company car versus employee's own car. Example 2. Rented diesel generator. Example 3. Rooftop solar electricity. Example 4. Contract manufacturing. Example 5. Rented office in a commercial building, mostly debated context. Example 6. Most common confusion. Example 7. Logistics. Example 8. Canteen fuel. Example 9. Waste management. Example 10. Employee transport by company bus versus city bus. Example 11. Captive power plant versus grid electricity. Last but not the least, a good way to handle tricky cases is to ask two questions. Who owns or controls the equipment and fuel use? Is the energy directly consumed as purchased electricity, steam or cooling, or is it self-generated? These two questions usually point you to the correct scope. Now, let's recap the final summary of what we have studied in this tutorial. Emissions and pollution. Air emissions. GHG emissions and its categories. Scope 1 and its categories. Scope 2 and its categories. Scope 3 and its categories. Emission factor. GWP. Kyoto basket. Some tricky cases.